Hey, Algebra 2, this is section 3.2. I'm going to get through about half of this today, and then we will talk about the rest of it on Monday, but we'll get maybe through example 3 is kind of where I want to get to. A lot of this is kind of new to you, so that's why I'm kind of going through a little bit slow, and hopefully we're retaining some of this information. 3.2 is solving quadratic equations by graphing, and we're really looking for the solution, or that's what it's asking for when we're solving. So we're looking for the solution, and the solution, another name for the solution, is the zero, or the roots, or the x-intercepts is really what we're trying to get to. When we graph a quadratic function, the solution is going to be the zeros or the roots or the x-intercepts. So if I look at the graph of this function here, this parabola, this quadratic function, the solution is going to be the point -2, which is where it crosses here, and -3, which is, +3, which is where it crosses over here. Those are my two solutions. The x-intercepts are -2 and +3. That's what I'm looking for as a solution, okay? So we're going to use kind of some of the same stuff that we used in the last section, which are the y-intercept. We're using the vertex. We're doing those things to graph, and then we're really trying to just find those roots and pinpoint where those are at, okay? Still dealing with things that are in standard form, ax squared plus bx plus c. And then the roots of the equation are often called zeros or solutions. That's what we're looking for, okay? Now, what you'll notice is what they did here and what they did here is -2. When we plug -2 in for x into this equation, that's the equation that is graphed here. When we plug -2 in like they've done here, we come out with 0. Okay, when we plug +3 in, same thing, it comes out to be 0, because this means that the y-coordinate is 0 when the x-coordinate is -2 or 3, because that's really what we're looking for. When we're trying to find the x-intercepts, we're trying to figure out when the y-coordinate is 0. And so since plugging -2 and plugging 3 in give me 0, that tells me that those are solutions to the equation, okay? All right, so let's go down here. Sometimes I'm gonna look at this box before we do example 2. Sometimes, or example 1, I guess. Sometimes you will have a function that has two solutions, okay, because it's a parabola, so it's going to go down and come back up. And this one has two solutions because it's hitting the x-axis there twice. But sometimes you'll have a parabola where he goes down, and then the vertex, that's this point right here, that vertex is touching the x-axis. So he really only has one solution. But then, even further than that, you might have a parabola that is completely above the x-axis that's not going to touch the x-axis at all, in which case there's no solutions, okay? If he's a frowny-faced parabola, he can also do that too when he's looking like this. He's not touching this x-axis at all here. So, doesn't matter, it could be a smiley face or a frowny face, and each one of these scenarios could happen. So, frowny face for one solution might look like this, where he's going up and touching once. Frowny face for two solutions might look like this. He's touching twice, okay? So that's an option. I can have two solutions, one solution, or no solutions. Now, can you have more than two solutions? Is there a way of having a parabola come and touch 3 times? Okay, well, in order for that to happen, your parabola would have to look like this, and then maybe you'd have to turn around and come back up again, right, in order to hit 3 times. But then it's not a parabola anymore, right? This would be like an x to the 3rd power function, where he does that kind of like s thing. So no, it is impossible for a parabola to hit more than 2 times. So it can either hit 2 times, 1 time, or no times on the x-axis. So that's what we're looking for as far as solutions go. Okay, so this is a scenario when we have two solutions that are happening. So they're going to have us do a table here, but before we do that, let's find the vertex and let's do the y-intercept also. Okay, let's do y-intercept first. If I'm looking at this function right here, what will the y-intercept be? We'll just remember that you're plugging 0 in for the x's, which make them go away, and -4 is going to be your y-intercept. Okay, -4 is where he's going to touch. And then if I want to find the vertex, the equation for the vertex is -b/2a. So negative b over 2a, negative b over 2a, remember that guy. My b value is going to be negative 3. Let's write these out. A, B, C, it just helps me. A is going to be the number in front of the x squared, which is 1. B is going to be negative 3. And C is going to be negative 4. So I have negative b over 2a, which is negative 3 over 2 times a, which is 1. All right, so that negative is going to turn to a positive. This is going to be positive 3 over 2. And if I divide that out, that is 1.5. Okay, 1.5 comma something. All right, now to figure out this something, I have to plug it back in to the equation. So let's erase this guy. I have 1.5 squared minus 3 times 1.5 minus 4. So 1.5 squared is 2.25. 3 times 1.5 is 4.5 minus another 4. If I put these two guys together, that's negative 8.5. And 2.25 minus 8.5, I'm trying to do this in my head. Let's say negative 6.25. I'm pretty sure. So negative 6.25. There's my vertex. At 1.5, negative 6.25 is about there. Okay, and I'm also going to do my axis of symmetry because I know that that dotted line has to go through there. So one other thing that I know, if here's my vertex and here is a point that lives on that spot on my y-intercept, this guy is 1.5 units away, so 1.5 units on this side is going to give me another dot there, and this is what my parabola is going to look like. Okay, I'm not going to graph him just yet because we're going to do a few more points. So we said 1.5, negative 6.25. They conveniently gave me the point 1.5 on that graph. Whenever you're picking points on your table, you want to make sure that you are putting the vertex as the middle point and then picking points on either side of that. Okay. All right. Now, for this table, we want to plug in the numbers negative 1, 0, 1, 2, and 3. They've already plugged in 4 for us. So let's plug them into this equation here. So I'm going to start with negative 1 squared minus 3 times negative 1 minus 4. So negative 1 squared is 1. Negative 3 times negative 1 is positive 3. And then minus 4. So 1 plus 3 is 4, minus 4 is 0. That's kind of interesting that this number and this number are all 4s, or both come out as 0s. That's not a coincidence. You know, we saw that kind of with the table that we've done before where both of those guys come out as being the same. Okay, now this one's probably going to match this one. So let's just plug 0 in. We said when we plug 0 into the x, out popped negative 4, right? We've already plotted that point. So this point 3 is going to be negative 4 also. And really, we have that point plotted as well already. Then let's plug in 1. That's the last thing that we have to plug in. So 1 squared minus 3 times 1 minus 4. 1 squared is 1. Negative 3 times 1 is negative 3 minus 4. And that is going to be, let's see, 1 minus 3 is negative 2. Minus 4 is negative 6. So each one of these is going to be a negative 6. So 1, negative 6. 3 is at, no, 2 is at negative 6. And he's going to do that. Okay. Let's see. That doesn't really tell me where my x-intercepts are, though. Let's do one more. Let's do 5. Let's plug 5 in and see if he comes out to be what we want him to be. So let's plug 5 in. I'm gonna add one more to the table. So if we plug 5 in, 5 squared minus 3 times 5 minus 4. 5 squared is 25. 3 times 5 is 15 minus 4. Ugh, we're not quite there yet. 25. Oh, yeah, we are. 25 minus 15 is 10. Minus 4 is 6, I believe. So 5. Oh, wait a second. 4 was at 0. There we go. We didn't need to do that. Okay, so we have all of our points plotted except this 4, 0 and negative 1, 0. So negative 1 is at 0, 4 is at 0. And I can draw my parabola that goes through all of those points. And we notice that the zeros are here. Those are the places where they intersect. So the solutions of my graph are at negative 1 and at 4. That's really what I'm looking at. I'm looking at those two places where they cross. Okay, let's go down and do example 2. This one is going to have one solution for us, all right? So the first thing that we have to do, though, this is kind of a mess. The first thing that we have to do is get everything onto one side. My equal sign is here, kind of in the middle of the entire problem. So I'm going to rewrite this down here, and we're going to kind of make him so that everything is on the same side, all right? The x squared is this guy here, and notice that there's a negative in front of him. If at all possible, I want to always try to make sure that that x squared is positive. So what I'm going to do is, that's going to decide which side I'm going to move everything to. So I'm going to take this x squared and move him onto this side because that's going to make him positive, okay? So I'm going to add the x squared over, add x squared over to here somewhere, and then the 14 I'm going to move as well. So I'm going to subtract 14 and I'm going to subtract 14. So on this side, everything is gone, so I write 0 equals. And then I just take these 4 pieces here and I try to combine like terms if I can. Okay, so the first thing I notice is x squared. He's a positive x squared. He has nobody that will go with him, so he just stays as x squared and I cross him off. Okay, the next order is just x, so I have minus 6x. There's nobody else that will go with him either, or no other like terms, so I cross him off. But then 23 and 14, those two will go together. It's a positive 23 and a negative 14, and that is positive 9, I believe. So that's what he looks like. Okay, so if I put everything together, that is what my new function looks like. So I'm going to write him off to the side over here so we don't get rid of him. 0x squared minus 6x plus 9. Okay, then let's go ahead and find the vertex. Well, let's find the y-intercept. Y-intercept, if you haven't figured that out already, is 9. So 9. Y-intercept is way up here. I'm putting him on my graph. Here's 8. There's 9. 9 is my y-intercept. Okay, then I'm going to find the vertex. So vertex, I do negative b over 2a. All right, a, b, c. A is going to be 1. It's the number in front of the x squared. Let me do equals 1. B is negative 6. And C is positive 9. So I have negative B, which is negative 6 over 2 times A. That's going to be a positive 6 over 2 times 1 is 2. So that gives me 3. 3 comma something, okay? Notice they did that again in the table here. They put the vertex as the middle number, which is what I want to have happen. Okay, 3, and then if I plug 3 into this equation here, I'm going to do it down here. 3 squared minus 6 times 3 plus 9. All right, 3 squared is 9. 6 times 3 is 18 plus 9. I've got 9 minus 18. That's negative 9 plus 9 is 0. Okay, so 3 comma 0. I'm going to put that right there. Okay, now, beautiful thing about this, if I know that this is a true parabola, the points that are equal distance on either side are going to be the same. So 1 will have the same y-coordinate as 5, 2 will have the same y-coordinate as 4. So I don't have to work as hard. Let's plug in 1 and 2, and then I can figure out what 4 and 5 are from there. So if I plug 1 in, 1 squared minus 6 times 1 plus 9. 1 squared is 1. Negative 6 times 1 is minus 6 plus 9. 1 minus 6 is negative 5 plus 9, which is 4. If I'm going too fast, you can sure pause the video. You know, that's okay too. If 1 is 4, then 5 is also at 4. Okay. 2, if I plug the number 2 in, 2 squared minus 6 times 2 plus 9. 2 squared is 4. Minus 6 times 2 is 12 plus 9. 4 minus 12 is negative 8 plus 9, and that is 1. So this guy's at 1, and so is that one. Okay, so if I graph this, I have the point 1 comma 4, 2 comma 1, 3 comma 0, 4 comma 1, 5 comma 4. Really, I also know 6 is up here at 9 because my y-intercept was at 9. So I could do that as well. And this is what my parabola is going to look like. The one solution is 3. That's what I'm really trying to find. And because he comes down and only touches at one spot, he only has one real solution. Okay? This last one that we're going to talk about, example 3, has no solutions. Okay, and this one says use a quadratic equation to find two real numbers with a sum of 15 and a product of 63. This sounds like a trig problem that we would do. But what we do is we say that they have a sum of 15. So let's say our numbers are x and y. Okay, x plus y has to be equal to 15. Okay, so my first number is x, my second number is y. What I can do is I can take this equation and I can rearrange it for y and get the y by itself by subtracting the x over. So I would say y is equal to 15 minus x. Okay, so my numbers are x and y, and when it says they have a product of 63, that means when I multiply x and y together, I get 63. So x times y equals 63, but instead of putting this x in here, they've plopped in the 15 minus x because they've gotten that from there. Okay, so yeah, don't worry about too much about making sense of that or having to do that by yourself. I won't give you a problem that starts, you know, with a story problem like that, but that's just kind of where that comes from. All right. Now, the next thing that I'm going to do is I'm going to distribute the x through. So x times 15 is 15x, and x times negative x is negative x squared. Okay, and then equals 63. Now I have the same problem here as I did on the other side, and that is I have part of it on one side, here's my equal sign, part of it on the other side. So what I need to do is I need to move my stuff, and I look at him first, the x squared. He is negative on this side, so what I'm going to do is I'm going to move both of these pieces over here, and that will make that x squared positive. Okay, so, I didn't want it to do that. Okay, so let's add the x squared over. I'm going to add x squared, and I'm going to subtract 15x, subtract 15x. Okay, so on this side, everything will be gone, so I have 0 left. And then let's just combine like terms if we can on anything over here and put them in order. So the first thing that I want to put is the x squared. This guy is the only x squared that I have, so I'm just going to rewrite him. Then I worry about the x's. I have minus 15x. He won't go with anything else. There's no like terms for that. And then I have 63, so I'm going to put plus 63, and that's what he looks like. Okay? All right, now, we're almost done with this because I'm not going to spend too much time. We're not going to find the vertex or anything like that on this one because I'm just going to show you how this works. Let's do the y-intercept, though. If I plug 0 in for x, that knocks these two terms out, so the y-intercept is 63. He's all the way up here at 63. So let's go by, I'm going to go by 5s. 5, 10, 15, 20, 25, 30. Oh, maybe I should go by 10s. 10, 20, 30, 40, 50, 60. This guy would be 70. So 63 is about right there. Okay, 63 is that guy. Shoot. Maybe we do have to find the vertex. I lied to you. We do have to find the vertex. So there's a y-intercept. Let's do the vertex. Negative b over 2a. All right, sorry. So a in this case is 1 again. B is going to be negative 15. C is going to be 63. Okay, so let's see. Negative b would be a negative 15 over 2 times a, which is 1. Okay, so if I take negative 15, that would be a positive 15 over 2, and that is 7.5. Now that only gives me the x coordinate to my vertex. Now I have to plug it back in. Last thing that we have to do, 7.5 squared minus 15 times 7.5 plus 63. Okay, I gotta go find a calculator. Nobody knew. Okay, I'm going to use my calculator, and I get 6.75. Okay, so 7.5, since we went by 5s, or went by 10. 7.5 comma 6.75 is going to be like kind of here in the middle. This would be 10 and 10. So 7.5, 6 point something is going to be about there. Okay. So if that's my vertex and he's going up here, he's kind of doing one of these. Okay. So in this case, because my vertex was already above the x-axis and we know he's going up, we know he's going to be a smiley face. You know, we can see that he's not going to touch this x-axis, so there's going to be no solutions in this case. We don't even have to plot points. I don't really even care, because regardless of what that parabola looks like, he's smiling, and his vertex is already above the x-axis, so he's not going to touch it all. Okay? All right, we will finish the rest of this on Monday. Hopefully I see you in school on Monday, and we'll just plan on that.